Hello and welcome to the series of lectures on big data. In the past few lectures, we are discussing about Hadoop, the core components of Hadoop that are HDFS and MapReduce. We have already discussed and talked about Hadoop distributed file system. What are the core components of Hadoop distributed file system and how these core components are working. We already know that Hadoop distributed file system has two core components. One is the name node and another is the data node. The name node are the metadata and data nodes are the commodity hardwares where actually the data is being dumped. Along with that, we also have a third core component or third node in this architecture of HDFS, which is called a secondary name node. Now, secondary name node, we can think it as a node where we are taking a backup of name node. It is not exactly a replica of name node. It is just having the backup of all the changes that we are making in the data nodes or the name nodes. Secondary name node is responsible for providing a process called checkpointing, where after every 1 hour, we are updating the edit log and FS image so that we can keep the name node up to date regarding its changes or updation that has been done in the data block stored in the data nodes. Now, in today's lecture, we'll continue the previous discussion and we'll understand how HDFS is dealing with fault tolerance and how the user can read or write on HDFS. So let us start. First thing, how Hadoop cope up with the data node failure. Because see, we know that all the data nodes are very cheaper devices. They are just the commodity hardwares, right? They are not the higher front of cost. So there are chances of being corrupted or being failed. What happens when any of the data node in the Hadoop architecture fails? So definitely Hadoop has to perform some fault tolerance policies, right? So let us understand that. We've already understand that if there is a file, we already know that if there is a file of any size, let's say XYZ. So here we have a file XYZ and the size is, let's say, 380 MB. 380 MB. What will happen here? Because the default size of dumping the data into the HDFS is 128. This is the default block size of data. So what we have to do, we have to divide this file into smaller chunks, where each chunk can be of lesser than 128 size or equal to 128 MB. Right? So I have to divide this 380 MB block into smaller chunks of 128 each or lesser than that. So let's say we divide them into 3 files, 120 MB each, 128 MB each. Right? So 2 of the blocks will be divided into the size of 128 and 1 will be divided into the size of 124. The size can be less also of the data blocks. This is the remaining block. Right? Let's name it as XYZ1, XYZ2 and XYZ3. So there are 3 blocks that we have received after dividing them into smaller chunks. Now, after dividing these blocks, what we are going to do, we are going to go to the name node. The client is going to send a request to the name node to write them, right? To dump them or to store them in the servers. So the name node will identify where we can store them and it will give you the address of that data node, right? So let's say we are storing in these data nodes, I'm storing XYZ1 here, I'm storing XYZ2 here and I'm storing XYZ3 here. Right? So we have dumped our data into the HDFS. The actual data is being stored on data nodes. Now imagine what happens at certain point of time if this data node stops working or this data nodes fail. So if this data node stop working, I have no other option. I will be having in the loss of this data block called XYZ3. It means the entire data which was dumped here must be lost, right? So there is no solution, there is no recovery of this data, right? So how HDFS is going to solve this problem? This fault tolerance can be solved with the help of a replication factor. Now, replication factor, as we have already discussed, is nothing but keeping the copies of each and every block in different data nodes. So here you can see in this diagram, I stored my 128 MB previously in this data node, second in this data node, and third in this data node, right? Let's say this is X1, X2 and X3. So I kept one copy of X1 here. I kept one copy of X1 here. Previously, we kept X1 here, X2 here, X3 here, and it was lost, as you can see in this diagram, right? We lost XYZ3. But now what we are doing, we are making the copies of all these three blocks, and we are keeping these copies at different locations, at different data nodes, right? If I have to keep these copies at different data nodes, what solution, how we are getting a perfect solution by performing replication? See, I am keeping X1 here and keeping one copy of X1 here. In the same way, for X2, we have used X2 here, we are keeping X2 here. For X3, we are keeping X3 here, we are keeping X3 here, we are keeping X3 here also. Now, in case at any certain point, if data node 3 stops working or fails, we might be in the loss of losing 128 MB data, right? But now what happens, because we have made a copy of X3 and stored it in some other device or some other data node, we can easily access that 124 MB file, which is X3, from some other data node, right? So in this manner, by performing replication or keeping the replicas of each and every data block into more than one machine in a distributed fashion, what we can have, we can deal with the fault tolerance, right? So this is how Hadoop distributed file system deals with fault tolerance. Now moving on to the Hadoop distributed file system. Now understand this. Hadoop distributed file system allows the user or the client to write as well as read the data. Now, while writing, we used to follow 3 steps. First is forming a pipeline, setting up a pipeline. Second, writing the data. And third, acknowledging the data. So, in these 3 steps, Hadoop distributed file system allows a client to write the data on data nodes. Now we already know in this diagram, you can see we already know these are the commodity hardwares where we are actually dumping the data. And this is just the metadata of these data nodes. So actually the client, while reading or while writing, has to deal with these data nodes. We'll be dealing with these data nodes. Then what is the use of name node while reading or writing? Name node will give you the permission whether you can read or you can write on the data nodes or not, right? So let us understand how this write mechanism works. As I told you, the first step is to set up a pipeline for writing the content, right? So initially there is a file, and because it was not in the block size, fixed block size, so we have to divide them into 2 components. One is known as block A, another called block B, and we are going to dump these files into this HDFS. So what the client will do or the user will do, first it will start copying block A. Now, as soon as you get the request from the user, HDFS client will create a request and send that request to name node. Now, what is that request? The request is to write the data on the data nodes. right? So at first stage, we will be creating and generating a request and we will be sending the request to name node. Write request of which block? Block A. Right? Here we'll be sending the information about block A, that what will be the size. Along with the name of the block, we'll be sending other information such as what is the size of that block, right? What is the source? What is the validation? And permission as well, right? All these information will be sending to the name node. Now, name node is the entity or the authority or the component which will allow you to read or write the data. So, we'll need the permission from name node. Now, what is that permission? That permission is nothing but the IP addresses or the address of the data nodes where we will be dumping the data, right? So, once the name node will get this request, it will return, after identifying, it will return the IP address of the data nodes where we can write the data, right? Now, before sending this IP address, your name node will check the permission, whether you are allowed to write on the data nodes, whether there is a space in the data node available or not, how many data nodes are free for that required space, and what data nodes are not working. Right? All these information will be identified by the data node before giving this address to the user or the client. Right? Once name node identify all these things, it identifies all the scenarios, it will send you the address of the data nodes where you can keep the data block. Now, block A can be stored in data node 1, in data node 4 and in data node 6. It means now we have the address of all these data nodes. So, once the HDFS client gets this input, this IP address, it will go to the core switch component. Now, these switches, they will send the control to the respective data nodes, right? So, the core switch will send the control to those switches that are having data nodes that will be sent by the name node. So, let's say here, you can see in the diagram, here switch, I'll name it as 1, I'll name it as 2 and 3. Switch 1 is having data node 1 or many more data also. In the same way, switch 2 is having data node 4 and data node 6. And in between, there might be more other nodes as well. In the same way, switch 3 might be having n number of data nodes. This entire structure is known as rack. This entire structure is known as rack. You must have seen the bookshelves where we have multiple racks where we can keep different type of books. In the same way, there is this entire rack where we have multiple data nodes. And on the top of this rack, we are having switches that are controlling these data nodes. That is communicating the information to these data nodes. In the same way, we have multiple racks where multiple data nodes are stored, and in each rack, we have a controller called switch, right? So, once we get the IP address of data node 1, 4 and 6, HDFS client will transfer this address to core switch. Core switch will go to the switches where data node 1, data node 4 and data node 6 are allocated. Now, data node 1 was stored at switch 1. So, the core switch will create and send this request to data node 1 directly, right? See, we are not communicating with other remaining data nodes. We are just communicating with the first data node that is being given, right? So, as soon as the core switch transfers the request to switch and we have the control over the data node 1, we can start writing. Now, before writing, we have only communicated with data node 1 to ask it whether it is ready for writing or not. Once the data node 1 is ready for writing, it will communicate with the second data node 4, to ask this data node 4 whether this node is ready to write or not. As soon as data node 4 agrees to write, this data node 4 will now communicate with data node 6. So, there is a chain. As you can see, there is a pipeline. First, client will send a request. Second, the request will be sent to name node. Name node will return this request to client. Now client will send a request to core switch. Now core switch will send the request to only one data node. Let's say data node 1. Data node 1 will communicate with data node 4 and data node 4 will communicate with data node 6. So there is this pipeline which has been formed. There is a pipeline which has been formed to write the content or the blocks on these data nodes. The process of writing will not start until unless all the data nodes have agreed on writing. As soon as all the data nodes agree on writing, the switch will pass the control to core switch and the core switch will again go back to the client to send an acknowledgement that all the data nodes are ready to start writing. And as soon as this acknowledgement has been received to the client, we can start writing. Right? So after setting up the entire pipeline for writing, we can start writing a block onto the HDFS. So there was a client, as you can see. We have already asked for the request and addresses of data node 1, 4 and 6. Now we can start writing. So the client will start writing. First, we will copy the content on data node 1. So I've copied block A here. And because by default, we need to replicate our data blocks thrice, so definitely 3 copies will be maintained. So the first copy will be stored at data node 1. After storing the block A at data node 1, then we'll move towards the second data node, which is data node 4, and we'll keep a copy of that at data node 4. So here we have already copied block A. Once the second replica has been generated and stored, we will request data node 6 to keep another replica. So we are keeping the third replica on data node 6. Right? In this manner, we have kept our file in a distributed manner, in replicated manner to deal with fault tolerance. Right? After writing, it means after dumping the data in HDFS, the last step or the last method is to acknowledge the writing procedure. So what happens here is, again, the first step will be the last data node that will be writing the replica of block A will acknowledge the completion of writing, right? And this acknowledgement will be sent to the previous data node because there was a pipeline which we have already set up. See, at the end, data node 6 will complete its writing. So again, the acknowledgement will be cycled in this opposite manner only. So data node 6 will revert back to data node 4 regarding the completion of writing process. Data node 4 will complete the writing process and send the acknowledgement to data node 1. Data node 1 will send the control to core switch, and the core switch again will return to the client. And after writing the entire data block on these data nodes, the HDFS client will acknowledge the name node as well. So you can see in this diagram, the acknowledgement will start from the last node. It will go up to the first data node. Then the control will be transferred to the core switch, and the core switch will acknowledge from the acknowledgement from all these data nodes will be sent by the core switch to the HDFS client. It means client node. And at the end, the client node will also acknowledge the successful write to the name node. This acknowledgement, this last acknowledgement is required so that name node can get to know that yes, all the writing in the data nodes has been completed and now it can update its edit log as well as FSMH, right? And after every 1 hour, we'll start the checkpointing process. So this is how entire write mechanism completes in HDFS. But this is only a single block. And because HDFS allows us distributed and parallel processing of data, so we are not only dumping block A at a time, we might be dumping more than one file at a time in HDFS. So here, that procedure or that mechanism is known as HDFS multi-block write mechanism. It means we are not only dumping a single file at a time, we are dumping multiple files at a time, right? So in parallelly, we'll be sending and generating the request for 1A as well as 1B. So you can imagine like this. Initially, the client node will be sending a request to the name node, and this request will be for both block A as well as block B, 1A and 1B, right? After identifying, it will send the addresses for both these nodes to the client node. Now the IP addresses will be overall 6 because we are dumping 2 blocks parallelly. So there will be 3 addresses. Let's say we have data node 1, data node 4 and data node 6. And for the second block, we might be getting data node 3, data node 7 and data node 11. We'll be getting this address. Once we get the address, again we'll start writing, we'll get the we'll start writing, we'll set up a pipeline, and after setting up a pipeline, we'll start writing the contents. So we'll dump 1A to B. So here first copy will be updated, second copy will be updated here, and third copy will be updated here for block A. And the same way for block B, parallelly what we are doing, we are keeping a copy here of block B, we are keeping a copy of here on block B and block B here again. Now you can see and you can ask this question that we are keeping the file in the same location. No, this is another individual commodity hardware and this is another machine. You can see and understand it like this. This is another system and this is some other server. There is only one rack because one switch is controlling these racks. That's it. So it means we are storing the data in distributed fashion. Alright. So 1 GB of file will be requiring 3 GB of storage in HDFS because we are replicating it thrice, right? And for block A, this entire pipeline is set up, which will be from 1A, 2A, 3A and 4B. And for block B, we'll be having 1B, 2B, 3B, 4B, 5B, 6B. This is the setup of pipeline. In the same way, the second step will be of writing these files in the same manner. And then we'll be getting the acknowledgement from all these data nodes back to the name node. This is how the write mechanism in HDFS is performed. Thank you very much.